A10C. So today we're going to be looking at another algebraic method to solve systems of linear equations. Hopefully you remember, because you should have just finished your quiz on elimination and how to solve for the intersection using elimination. Today what we're going to do is look at the second method, which is substitution. So again, this is a step-by-step algorithm that you need to memorize. And so for that reason, get your paper and pens out. Please write these steps down. It's very important you do that. So pause the video, make sure everybody has their stuff together, and then let's continue. So today we are solving systems of linear equations algebraically, and specifically today we are looking at substitution. Okay, so first of all, let's look at an example. The best substitution questions are set up differently than those of elimination. Remember, elimination, everything is lined up in its own column, and then you add or subtract to ideally eliminate a variable. Substitution questions, and so if I said solve using substitution, that means I want you to find the intersection of these two equations, and I give you these equations. 4x plus 5y equals 26, and 3x y minus 9. So let's say I gave you those two equations. Now, my first step in substitution is obviously going to be a bit different than elimination. So the first thing you need to do is you need to solve to get the easiest variable by itself. Solve to get the easiest variable by itself. And so if I look in these two equations, what is the easiest variable to get by itself? Is it 4x or 5y in the first equation? Is it 3x or y in the second equation? Now, for me, if I'm looking at this, I think y is the easiest to get by itself in the second equation because I don't have to divide by any coefficients, which means I shouldn't be dealing with any fractions. So, what I want to do then would be 3x equals y minus 9. And all I need to do to get y by itself here, just use Sam Deb. So the opposite of minus 9, I'd add 9. What I do to one side, I do to the other. Remember, these are not like terms, so this would just be 3x plus 9 equals y. And for the sake of us writing notes right now, I'm going to call this the rearranged equation. Okay, so that's my first step. It's pretty easy. I'm also going to add a note here that I say solve to get the easiest variable by itself, but really, you can get any variable by itself. That is not necessarily you have to do that. You can get any variable by itself. It just makes our life easier. So note, you can get any variable by itself. Again, I'm just choosing the easiest. So, now I have this rearranged equation. My second step, and I'm going to start this on a new page, so hopefully you guys all have that written down. The second thing I need to do here, let's go back to black and black. The second thing you need to do, what we're going to do is we're going to substitute, hence why this is called substitution. We're going to substitute the rearranged equation into the, what we're going to call the other equation. from last time, we just figured out the rearranged equation was y equals 3x plus 9. The other equation, the one I haven't touched yet at all, is 4x plus 5y equals 26. So I'm going to take that and substitute it literally into the other equation. So wherever there's a y, I'm going to put 3x plus 9. So wherever there's a y, I'm going to put a 3x plus 9. So it's that whole equation is going to substitute in for y. So what that looks like is 4x plus 5 times by that entire equation. 3x plus 9 equals 26. And at this point, I know that I'm on the right track and doing my substitution correctly because I only have one variable left right now. So we should only have one variable left, and what we're going to do is solve for it. Go back to blue for my example. Okay, so if that is the only variable that's left and I need to solve for it, to properly solve for this, what I need to do first of all is get rid of these brackets. Yeah, I have to solve using SAMDEP, but solve for brackets. Get rid of these brackets first. So I would use the distributive property to multiply that in. This 4x doesn't change at all. Plus 5 times 3x is 15x. Plus, 5 times a positive 9 would give me a positive 45 equals 26. So to solve for the remaining variable here, I would combine my like terms. So 4x plus 15x is 19x plus 45 equals 26. Now if you wanted to get rid of the 45 up here, you could have done that. So this next step here is kind of the equations that we've been dealing with more in terms of rearranging. So to get x by itself, I solve using SAMDEP. So get rid of subtraction or addition first. So I would subtract by 45 to get rid of the positive 45. What I do to one side, I do to the other. The 19x hasn't been touched, so I'll bring that down. And 26 minus 45 is a negative 19. And to get x by itself, the 19 and the x are being multiplied. So to undo that, I would divide by 19. And again, what I do to one side, I do to the other. So x is equal to negative 1. Now that I know what the x value of my point of intersection is, I'm continuing the same process that I did for elimination. I'm just taking this value and substituting it into either equation to figure out what the y point of my intersection is. If you don't have that all written down, just take a quick second to pause it. I'm going to move on to the third step, which is again, from this point on, is the exact same as elimination. So, my third step, same thing as elimination, which is, what we're doing is we're insert the solved value into either equation. So insert the solved value into either equation and solve for the other variable. Now, when you do this, make sure that you're inserting that number into the original equations, just in case you made a mistake rearranging or something. So we just figured out that x is equal to negative 1. And the two equations that we have are 4x plus 5y equals 26. And the other equation that we started with was 3x equals y minus 9. Now, whatever equation I decide to substitute this into does not matter as long as I'm solving for y. And in my opinion, I always like to do it to insert that x into the easiest equation And so to me, this guy here is the easiest equation. So I'm going to take the -1 and substitute it in for x. So I have 3 times -1 equals y minus 9. And it's the easiest equation because I'm not having to, divide off anything. Y is already by itself and I need to solve for it. So 3 times -1 is -3 equals y minus 9. And to get y by itself, we would add 9 to either side. So y equals 6. So using substitution, we just figured out that the intersecting point of this graph, so therefore -1, 6 is the intersect. So there's my final answer. Now, like I said previously, the best part about this section in math is we can tell whether or not we have the right answer, right? I know whether I'm 100% sure because I can verify this using one of two strategies. And so this is always your optional fourth step. Your optional fourth step is to verify either algebraically or graphically. So our point is -1, 6. Sorry. And my two equations we started with was 4x plus 5y equals 26 and 3x equals y minus 9. Now, if it was up to me, I would choose to do this algebraically because I always find students make more errors rearranging to put on their graphing calculator to verify the answer rather than solving algebraically. And algebraically, you can just type it in on your calculator really quickly. And so hopefully everybody remembers how to figure out if to do this algebraically. We would put in the -1 for x and the 6 in for y in both equations. And if we've done our work correctly, the left side will equal the right side. So 4 times -1 plus 5 times 6 hopefully equals 26. So we're kind of trying to figure out. So 4 times -1 is -4 plus 30. Again, we're hoping that equals 26. And -4 plus 30 would give me 26. So 26 equals 26. That's good. Remember, that means that this point, -1, 6, is on that line. Now let's check for our other equation to make sure that point is on the line. If that point is not on the line, it can't be the point of intersection. So I would go 3 times -1 equals 6 minus 9. So -3 equals 6 minus 9, which is also -3. So that is good. That also means this point, -1, 6, is on this line. So we know 100% sure we just did our substitution correctly. Okay, so I know it's a lot, but again, once you get those first two steps for substitution out of the way, it's solving in the exact same manner that we did with elimination, and then you're just verifying your answer. So let's take a quick look at one more example here. Okay, so here's the example we're going to look at. So if again, I'm just saying solve using substitution. And you do have to know how to use both of these algebraic processes to solve for an intersection. It's part of the curricular outcomes. I will ask you on the unit exam, solve this question using substitution, solve this question using elimination. You have to know both processes. So here's the question. X plus 4y equals 17 and 2x minus y equals 7. So if I'm gonna, almost fell. I have to stand on chairs in order to reach the top of the board. Alright, first thing I gotta do is rearrange, and you don't have to write these steps down, I'm just rewriting them down. Rearrange for easiest variable. Now, looking at these two, I guess discuss with the people next to you who you think, or pardon me, what you think would be the easiest variable to rearrange for. In my opinion, I would say this guy right here is probably the easiest variable to rearrange for, because all I need to do is move the 4x to the other side. I don't want to deal with the 4y here because I don't want to have to subtract and then divide if I can avoid it. Same thing with this x here, and I don't want to deal with this negative y because I'd have to move something and then divide by negative 1. It's just the least amount of steps to isolate that x. So x plus 4y equals 17. But again, it would not matter which one you isolated as long as you isolated a variable. So to get x by itself, I'd minus 4y and minus 4y. So x is equal to 17 minus 4y. I would not combine those. Remember, those are not like terms. My second step, so the second thing I need to do here is substitute that rearranged equation into the other equation. So substitute this into the other equation. So I'm taking, that is not how you spell equation. I'm taking this and I'm going to be substituting it into 2x. Sorry, I need to change colors here. Into 2x minus y equals 7. Because we have rearranged for x here, we take it and we substitute it, that entire equation, in for x. So this would be 2 times 17 minus 4y minus y equals 7. And I know at this point I have rearranged or substituted, properly, because I am only left with y, and I need to solve for y from here. To do that, we should always probably have some sort of multiplication I need to do, so I will distribute out that 2. So 2 times 17 is 34, and 2 times negative 4y would give me a negative 8y minus y equals 7. So then to properly solve here, I would combine my like terms. So negative 8 minus y, so negative 8 minus 1 would give me a negative 9y. And at the same time, I'm going to minus 34. Minus 34 equals a negative 27. Then properly to get y by itself, I would divide by negative 9. And negative 9. So y is equal to a positive 3. Make sure you would cancel out those negative signs. That would be a very common mistake, which would then give you the wrong corresponding x value. If you checked your answer, algebraically, you would always know that you found the wrong value. So now that I have found the y value of my intersection, I then need to figure out the corresponding x value of my intersection. So I would, again, same thing as elimination from here. I take that y value and I substitute it into either equation. We just figured out that y is equal to 3. And I need to, my third step would be just to solve for x. This should say by inserting y into either equation. Just to rewrite my equations, my original equations, again, make sure you have to go to original equations. X plus 4y equals 17, and 2x minus y equals 7. You guys probably don't need to keep writing down the equations, but I do because I had to start a new page. So I'm taking that y and substituting it in to solve for x. Probably putting this into here makes it easier because then I don't have to divide by anything to solve for x. So x plus 4 times 3 equals 17. 4 times 3 is 12. And then x plus 12, so to get x by itself there, the opposite of adding 12 would be to subtract 12. What I do to one side, I do to the other. So x is equal to 5. That means, therefore, the point, which would be x comma y, so it would be 5 comma, oops, not negative 3, 5 comma 3 is the intersect. And your last step should always be verifying it. It's not a necessary step, but it definitely will help you on a quiz or test or a review assignment. So we would verify. The two equations, again, are just up at the top of the page there. So I'm inserting this in for x and this in for y in this equation and into this equation. So it would be 5 plus 4 times 3, hopefully equals 17. So 5 plus 12, that equals 17. So we're good. That means the point 5 comma 3 is on that line. Then we would do the same thing for the next equation. So putting this into here, 2 times 5, which is 10, minus y, which is 3, needs to equal 7. Well, 10 minus 3 is 7, so that is also good. Because the left side equaled the right side for both of those equations, that means we properly found the intersection using substitution. So you can go ahead and do the questions that the substitute will give to you. They are on page 629, numbers 1AC, 2AC, 3, 4A, 6, and 8. Please try at least these 4 questions. I would like to see those 4 questions done when I'm back tomorrow, because tomorrow we're going to go look at creating equations from real life problems and then solving them using substitution, kind of the same thing we would have done the second block on Thursday. If you come across any questions in 1 or 2 or 3, any of those where you don't have these nice equations where you already have a variable without a coefficient, that's okay. You can still get that variable by itself by dividing. Maybe it works out that you end up with nice numbers, or maybe it ends up that you deal with fractions. That can happen. It just makes your life a little bit more hectic trying to keep track of everything, but the solving process is exactly the same, regardless of what the numbers are. Okay, so hopefully that helped, and hopefully you understood everything. I will see you guys tomorrow.